And up next is Gerard from Belle telling us about development at NPOI.
Very good. How's my audio? Very good.
Yep.
Oh, very good. Thank you. Let me do the screen share. Here we go. And hopefully that looks good. Well, that's a hard act to follow. That's some really exciting stuff going on at LBTI, and it's really neat to see. Thanks, Jordan. I'm going to talk a bit about things that are going on at NPOI. That's actually where I am currently physically at right now, is here at the site. And a lot of work going on, which got in the way of me actually coming out to Exeter, which is unfortunate. But let me give you a taste of the various things that are happening here. The current status of NPOI is that we have full 6-way beam combination that has been basically put back online. I'll talk a bit about that. We have our classic beam combiner, and then we have quite a large number of ongoing upgrades that are actually charging ahead full steam. We've had some support for the site that has been something we've been trying to get for some time. And the important thing is we've had quite a number of hires that are associated with that, and a kind of a newly rejuvenated engineering team that's going to be working on these various things. So let's actually look at what we're working on here. So like I said, the current infrastructure here is we still are doing siderostat fed operations. And so that's largely based around 12 centimeter apertures. That's the effective aperture for collecting light from the sky. And that includes 6 of these so-called imaging apertures. And then additionally, there are 4 of the astrometric apertures that were built in as part of the milliarc second class astrometric experiment that had been going on here. That specific experiment has been retired. And we currently have baselines out to 79 meters, where we can combine 6 apertures that take us out that far with the smaller, shorter baselines in between. The aperture size does limit our current sensitivity right now to about a visual magnitude of about 5 or 6. And then we have 6 of these variable optical delay lines of the kind of JPL vintage that are the same heritage that were found at Palomar and Keck and Chara, as well as NPOI, with the roots in the Mark III. All that is from the same technology family. We're in the process of adding larger apertures for this. This is support from one of our partners, the Naval Research Lab, that has gotten that going. And so we have those 3 1-meter telescopes are on site. This little animation here is of the factory acceptance that we did, but they actually have all been delivered here. And the idea here is to basically get ourselves down to limiting magnitude of about 9 or 10. Basically put us in the same class as Chara. These are located inside of relocatable domes. You can see us tugging this around here with our Bobcat. And we have recently located 2 of these 1-meter telescopes right next to each other for the initial commissioning fringes that we're working towards getting this over the course of this calendar year, probably before the onset of monsoon season in mid-July. And so we're going to start off with a relatively short baseline just for the engineering demonstration of about, I believe the measurement is 7.8 meters to get us started. And that'll be very exciting because then we'll be able to feed that into the array. Once the light is sent into the array is largely agnostic about where the light came from, and the beam combiner will merely put it back together and give us a signal. We are not set up to combine the larger telescopes with our siderostat feeds because of very different front-end beam trains in terms of the front end for the siderostat is basically a reflection off the siderostat, and then we are into our vacuum system. Whereas with the 1 meters, it'll be off of the telescopes through either a fast tip tilt or a adaptive optics system, through a Cadet train, and then a relay into the vacuum system. And so there's going to be bad polarization and image rotation mismatches. And so the 1 meters get used with 1 meters and the SIDS get used with SIDS, and that's life. In addition to the 1 meters, there are some other elements of upgrades going on in our laboratory, and that includes a new fringe tracker, sorry, a new angle tracker for the fast tip tilt on the laboratory side of things. And the idea there is we've used a avalanche photodiode system since the inception of the site, and we're changing that out finally for a system that uses a more modern EMCCD. This actually had initially begun installation in March of 2020. And my colleague seen in the picture here, Dave Mazurkowicz, was most of the way through the installation and was kind of unceremoniously evacuated from the site when we shut everything down for COVID. And so that interrupted that. But basically the design is complete and the part procurement is complete. And even most of the installation is complete. But we just need to wrap that up. In addition to that, basically on a level below that on the same table, Dave has also been getting a near infrared fringe tracker initially put together in his lab back in Maryland. And recently he's been allowed to come back to the site with COVID on the wane, and has installed a near infrared fringe tracker. And so this table will support both the operations of that angle tracker on the previous slide, and then this near infrared fringe tracker. And the idea here is we want to work on co-phasing very long baselines by basically using the longer wavelength on short baselines to get high signal noise. And the idea here is that we're going to use this near infrared fringe tracker in conjunction with our visible light beam combiners, and then let the visible light beam combiners have longer coherence times because of the co-phasing from the near infrared fringe tracker. Speaking of visible beam combiners, we've been in the process of reactivating Vision. Vision was kind of our next generation beam combiner that is based on fiber-fed beam combination into a V-groove array. It's a lot like the original Merck out at Chara, but in the visible rather than in the H and K band. And it's kind of hit dormancy for a while due to lack of support. And again, with our newly expanded engineering team, we were able to try and get this back online. We've unfortunately found that the EMCCDs that we had in service for this had both developed a vacuum leak in the cryostat. The manufacturer, who will remain unnamed, pointed out that this is a design flaw that is known, and oh, by the way, you're out of warranty. And so we've shipped them off to that manufacturer for a fix, and we should get them back soon. And the idea is that we will be trying to integrate the new angle tracker and this new fringe tracker with the visible light vision combiner, and use them all in unison for greater sensitivity with both the existing stereostats and then ultimately the 1 meters as well. In addition to all that, we've actually returned as of last fall to 6-way beam operation. The facility, again, with previously lack of manpower and other lack of resources, had kind of fallen into a bit of disrepair in terms of the previous era of 6-way fringes was actually a bit more than a decade ago. And so we're really, really proud to have gotten back to the point where all 6 delay lines are functional, and we are collecting data and combining light from all 6 apertures now whenever we're on sky. And as you know, we get, of course, with every additional aperture that you go beyond, say, 3 or 4, where we've been previously, you get a big increase in the amount of data that you're getting off of any individual source. All of this connects to the fact that, like I said, we've gotten some additional resources to work on this. This is what we call the so-called plus-up funding. And the intent of this funding is to address, a decade or so of deferred maintenance and a lot of infrastructure that has never been fully completed here at the site. including our long delay lines that complement our actual fast delay lines. We have an architecture a lot like Chara, where our LDLs are the analogous to the Chara POPs, and our FTLs are actually almost at the part number level compatible with the similar fast delay lines out of Chara. We're trying to also get operations improved and just basically position ourselves for robust operations for the next decade and forward. Make ourselves really competitive for pursuing grant money and true science. And so that's roughly funded at about the $11 million level. And we've got a very long list of punch list items to remedy and upgrade at the site that we're now chopping through with a freshly repopulated engineering staff here. This includes even mundane things like buying a bobcat for moving stuff around and pulling our telescopes around. Other things such as 20-year-old IT infrastructure and other sorts of safety devices. There are elements of the array which show their age. For example, one of the things we are working very earnestly towards is the long arms of the array. We want to get the longest arm of the array functional at 430 meters. Once we demonstrate the short fringes with the 1 meters, we're then going to immediately leapfrog to the 430 meters. And the problem is the east arm had poorly built foundations, and the pipes are actually not straight for the vacuum beam relay. And so we're straightening that out. So a lot of civil engineering going on out at the site right now. And then other things like upgrading our electrical array and other sorts of things, putting in an auto aligner. Again, following on some similar sorts of upgrades at Chara, and make it so the site operations are much more efficient. While we have the 1 meters on site and before they are feeding into the array, they're actually being used individually in a fully robotic mode right now, where we give it lists of asteroids or stars for light curves or that kind of thing. And they actually chug away every night doing their own thing while they await ways to relay the light into the system. Last couple of slides here. I think the upcoming milestones are we've let a commercial contract for full adaptive optics for each one of the 3 1-meter plane waves. And so we have an interim system that we've been using, but that'll be upgrading soon to a full commercial system here. We expect delivery of the first system in the fall, in November or so. And then in advance of that, we have like I said, kind of a stopgap tip tilt system, and we'll be able to relay the light in. And so we're trying to work towards a setup where we can relay the beam into our vacuum beam relay by, like I said, before the monsoon season hits, and see if we can get first fringes with roughly our 8-meter baseline, and then ultimately quickly go over to near infrared fringes. I think that is all my slides here, and I would love to take any questions if people have questions. Thank you.
Thank you. Questions? Yes.
Hi, Gerard. It's great to hear that lots of things are happening at NPOI. You mentioned that you have a refreshed engineering staff. I was just wondering how many people you actually have now.
So we have in each of the categories of mechanical, software, and electrical, we have a full-time hire on that. There's also a full-time project manager that we've hired to manage all that. There are a number of engineering interns that we have from the local university here, the Northern Arizona University. And that's actually just the Lowell staff. In addition to that, there are some NRL employees as well. Jim Clark, the director of the array, has quite a bit of talent with mechanical engineering as well. And so he's here most days, as well as other optomechanical staff that come in on the NRL side as well. And so it's gotten quite busy here at the site. It's very exciting to see the parking lot full every morning. So that's a big change from a couple of years ago when we had 1 or 2 staff that would be here regularly. We also have 2 full-time staff just for site maintenance. So that includes groundskeeping, but also the vacuum system upkeep, which bands between the pipes need to be tightened and maintained, and the other sorts of things that are just for the health and safety of the site. So it's a busy time here, which is great.
Great, thank you.
And if there's no more questions, then we'll change to the next speaker, but let's thank the speaker again.
Thank you.